Good evening, dear students. So today we are going to discuss the work, energy and power unit test questions. So the first we'll be discussing the 5 descriptive questions followed by the 15 objective questions. So I hope all of you are able to view the screen, and I'm going to upload the first question, first descriptive question. So that was the first, descriptive question, as you see in the screen. So what is the value you got, Shrest?
7.
Very good. Pratik? Dear Pratik, what is the value you got?
7.
Okay. Okay, so you got the value as 7 meter per second. And good that all of you got it. And I hope I no need to explain further as all of you got it. Now let me proceed for the next question. I hope you're able to view the question. Correct? Okay. Please do let me know what is the value you got for the second one. Pratik?
Sir, I didn't get this.
Okay, I will discuss.
So I also didn't get.
Okay, so then let me explain. Let's first go through the question and let's explain. All of you are able to read the question very clearly, right? It is visible, or do you want me to send in?
Yes, sir, it's clear.
Okay. As shown in the following figure, the spring of spring constant K is undeformed. Find the work done by the variable force F, which is always directed along the tangent to the smooth hemispherical surface on the small block of mass M to shift it from the position 1 to the position 2 very slowly. Dear students, that position 2 is varying, and how we are measuring that variation from with respect to the position 1 by means of that angle theta. So definitely, the variable force depends on theta 0 in fact in this case, and obviously there are few um, other constant thing that we need to discuss, that is that mass m, g, a and k, all these are constant, but theta 0 is variable, and that is why it actually gets it is a variable one. The thing is that how we can proceed to this question. from the condition of equilibrium of the block due to very slow shifting at any arbitrary angular position theta, which is less than theta 0, okay, what it will be? It will be mg cos theta plus kx, obviously, isn't it? Okay. Let me share the entire solution followed by its explanation. So what I'm saying, dear students, is that, from the condition of equilibrium of the block due to very slow shifting at any arbitrary angular position theta, which is less than theta 0, obviously there will be two things. One is mg cos theta and another one is that kx. Correct or not? So that is the, we get this is the value of f. Work done in displacing the block through a distance dx is dw, because for the small distance of dx the work done is dw, so it will be dw should be f into dx. So f we already derived mg cos theta plus kx into dx. Now we know obviously x equal to a into theta, we know, and dx should be a equal to d theta. So total work done will be what? Total work done will be from, it's an integration, correct? So from 0 to theta 0, because 0 is the position, 0 is the angle at the position 1. Obviously one thing you understood, the amount of force will actually get increased when you move it from the position 1 towards the position 2. I'm sorry, the amount of work done is actually getting increased when you actually move from position 1 to position 2. Correct, no? So then what happened is that, integration will be f dx. So 0 to theta 0, mg cos theta plus ka theta a d theta. And if you find out, you'll get this is the value of the work done. And if you see the work done, dear students, if you notice that it actually getting increased as we increase the value of theta 0. Correct? Clear or not clear? So, from 0 to 90 degree, obviously theta is increased from 0 to 90 degree. Any doubt here, dear students, before we proceed to the next question?
No, sir.
Dear Pratik, Tejash, clear?
Yes, sir.
Okay, great. So, let me proceed to the next question. So this is descriptive question number 3, dear students. You can let me know what's the value you got if you have done it. Shrest, Pratik.
Sir, is it 1.7?
1.72.
You got the value as 1.72 meter per second, right?
Yes.
Yes, sir.
Absolutely, that is a correct answer. Dear Tejas, what you got? Hello, dear Tejas? No answer from you? Okay. So just for the sake of sharing the solution, let me share it. So Tejas, you can have a look into it later, and do let me know what you think. It is quite self-explanatory. First, you need to draw the free body diagram, and after drawing the free body diagram, things will be well understood.
Sir, it seems his mic is not working. That's why he got the
Okay,
answer.
okay. Great, good. As all of you anonymously said, it is correct answer. So I'm not discussing. Rather, we should discuss where you need my explanation more important. So this is the entire derivation as all of you got it. So I'm not discussing in details. So rather, let me proceed to the next question. That is question number 4. So this is question 4, dear students. So Pratik, able to do? Shrest, what is your answer?
So 0.5 meters.
0.5 meter. So you are telling that the distance moved by the block on the plane.
Yes, sir.
Pratik, you also got the same value or different?
Sir, I got the same.
I don't think it is correct one. So let me explain you the problem. So first of all, let us consider the following diagram. If you look into the diagram A, let the picture come. Yeah, the diagram A represents the case when the bob is just released, and the figure B represents the case when the bob has rebounded. Correct, no? So the point here, what we can find out is that if we consider V1 be the velocity, if we consider V1 be the velocity of the bob when it hits the block, and in this situation we see the loss in potential energy of the bob must be equal to the gain in the kinetic energy of the bob. Okay, so we can form, the following mathematical equation. Just have a look into it, and first let's go step by step, and do let me know if something is not clear. Correct, no, dear students? All of you agree to me? So we get the value of V1. Now after rebound, let us assume the velocity of the bob be V2 and the velocity of the block be V3. Since the bob rebounds through an angle beta, we get some mathematical equations, okay, from the fact that the loss of kinetic energy of the bob should be equal to the gain in the kinetic energy of the bob. So that's why I said step by step. Unless you go step by step, things may get jeopardized.
So, but this can't be the velocity of the block.
Why not?
Because the bob goes back beta angle. So potential, if all the energy, potential energy gets converted into kinetic energy, there's no energy left.
Now, if you look into this one, that we assume that v1 be the velocity of the bob when it hits the block, right? No. And in this situation, what happens? So let's first understand. One thing is for sure, the loss in the potential energy of the bob must be equal to the gain in the kinetic energy of the bob, no? Correct?
Yes, sir. But see, when MGL 1 minus cos theta is the potential energy in position in figure A. So when
Correct.
it reaches the uh, like mean position, it hits the mass and then it rebounds to the angle beta. So
No,
that potential they also should be counted. That should be some.
no, we should not count that one. We are just thinking about the situation when that bob is actually hits the block. Correct, no? When
Sir,
the
when it hits the bomb, the,
that
if
I'm
all the
talking about,
potential.
I am talking about that moment when the bob is actually hits the block. At that moment, what will be the loss in the potential energy in the bulb? That you tell me. It is mgl into 1 minus cos theta, no? Correct?
Yes, sir.
And that should be equal to what is the gain in the kinetic energy, correct? That block velocity should also be v1, no?
So, but when it hits the mass, it again rebounds. So it again gains potential energy. So that
Ah,
also we have to take in
ah,
account.
that is we are considering after rebounding. That let me complete this one. No? That's what I'm saying. But why you are not okay? Let me complete this thing. Then complete this part. After rebound, what will happen? That the velocity of the bob be v2. It cannot be same, right? Now, okay. Let's assume it is v2, and the velocity of the block that also should not be v1. Let it be v3 after rebound, not at the moment of rebound. Now, as we see that the rebound angle is an angle of beta, so we form the following equations. What is the equation we can form here? It is something like this. Let me show you the equation first. Let it come. Yeah, did you get this one? That mgl into 1 minus cos beta should be equal to half mv2 square. So from there we find the value of V2 is equal to root 2 meter per second. And we then apply the conservation of momentum. So total momentum before the collision should be equal to the total momentum after the collision. What is the total momentum before collision? M into V1. And what is the momentum after collision? M into V2 plus capital M into V3. From there we found the value of V3. Tell me where you find things are not according to the logic. And after that, you need to bring the concept of friction here. What is the frictional force? You need to compute the frictional force. Frictional force will be mu into capital M into G, na? So let me bring that part. I'm just writing, line by line so that you can follow it. If I put side by side, you could have say a little better, but I think it is okay. So frictional force we found 0.4 Newton. So retardation of the block motion, definitely it should be 0.4 by 0.2 because the velocity you already found out. So S is the displacement happened. From there you found the value of S. Dear Shrestha, please do let me know where you find, you have any different statement. And Pratik, you can also provide your comments. Or you can send me your, in fact, the solution, what you send, it is not very detailed explained, Shrestha. I got your solution.
Yes, sir, I got it.
Okay. Shrestha, do you agree to me, the solution? Yes, Shrestha.
1 second, sir.
Yeah, please take your time.
Yes, sir, I understood.
Correct. No? Okay. All right. So let's proceed to the next question. That is question number 5. And you will get the question 5. And that's why. Okay. Before proceed to question number 5, question number 4. I analyze the problem step by step. What are the step of events happening actually? So these are the things I explain step by step. Apparently, if you see the problem, looks like the problem is little complex, but it is not.
I joined 2 sets together, so that then I made a mistake.
No issue, no issue. Mistake happens. Mistake is not is not at all a big deal. Only thing is that the practice what makes most important thing. Okay, the descriptive question number 5 will be in front of you another few seconds, sorry. Yes, you can let me know what are the solutions you got for all the 3 plots.
So I got 154.2 degrees.
For the first one,
Yeah, yes, sir.
okay, Pratik, you also got the same thing.
No, sir, I got 53.
Precisely correct. 53 is the very correct answer, Pratik.
Velocity is 3 and the maximum height is 1.2.
Maximum height is 1.2. that you got for the part 3, right? Yes, it is near 2.1.2, correct. Okay, so let's discuss rest. Okay, let's see why you got such a big angle. Let me first, describe the. Let me first draw the diagram, and then let me. I hope you have the question accessible to you. So it's not a big problem that if I make that question invisible, as I need to show you the solution. Let me put it like this. So I hope you get the picture is self-explanatory. Stressed. So the only force acting on the particle at P is its weight mg. The radial component of the force is mg cos theta, isn't it, dear stressed? Now as the particle moves on the circle up to P, we get the equation. What is that? Mg cos theta should be equal to mv square by L. Correct or not? Let me show you this thing. Dear stressed and Tejas, please feel comfortable that you understood this equation. Correct, na? Okay. Stressed unless you say yes or
Yes, sir.
I may
I
think.
was just I was just matching with what I did.
Absolutely. Why not? Why not? Why not? You should take time. No hurry. Because this kind of problem you should spend time.
Yes, sir. I took the angle from the horizontal by mistake.
Okay. But see, the mistake is very costly, huh? One small mistake will, reduce the rank by few hundred. Now, if you look into the, the derivation, what I did, first we applied the conservation of energy, and from there we found that value of V, and eventually the value of V0. And according to the question, we get V0 equal to square root of 57 meter per second, L is equal to 1.5 meter, as you see, and G is equal to 10 meter per second square. So we applied all these values and find the value of theta equal to 53 degree. And not only that, stressed, the value of theta you got, if you look into it, that is not very practical, isn't it? Do you agree to me? The value of theta you got? I understood you took it with the horizontal. That's why the mistake happens. No? Correct or not?
Yes, sir.
Okay. Okay. No problem. So,
So I'll just do myself and then I'll see again.
absolutely. Absolutely. And let's come to the, part B. Part B, what is the value you got? I think you also got mistake, because if part A is not correct, part B should also be incorrect. No? So
Yes, sir. I
and
got
so
all the answers.
yeah, eventually it will get, because it is dependent on that angle. So Pratik, you got it correct. So just I'm just informing it to Shrestha and Tejas so that you can follow it later. I hope things are clear. Okay. Now we can proceed to the objective questions. Let me pull the question first.
Sir B.
Pratik, what you got? Dear Pratik, you also got B?
Yes, sir.
Correct. Great. So I'm not discussing that solution then, as all of you got correct. Let me come to the next one. Yes. For the next one, what you got?
Sir D.
Sir, I didn't get
You didn't
this.
get this. Okay, let's discuss. But Pratik, your answer is absolutely correct. It is D indeed. Okay, so let's discuss rest. So if we go through this one, and what we can if we go through the statement in the question, one thing we can definitely conclude: the loss in elastic potential energy is definitely equal to the work done against friction. So what is the loss of elastic potential energy is equal to half into k into x square. And what is the work done against friction? Mu into m into g into x1. And from there we need to just find the value of the mu. Correct or not? Let me show you. Dear stressed, in fact, you can let me know that what was the issue that you didn't approach, or you got something different. Hello, dear stressed.
Sir, I
No issue.
He doesn't know anything.
Okay, so let's proceed to the next question. So this is the third MCQ. What is the answer you got, Pratik? And Shrest, Tejash?
Sir, A.
Okay. A is not the correct answer.
Sir, B. Sir, B.
B? You're talking about B? B as in Bombay?
Yes, sir.
Neither of this. It is neither A nor B. So what happens here? If we consider A be the force acting on the particle, so we can find the value of F in terms of U. How? F is equal to minus du dx, correct or not? It is actually D. Let me show you how we got D as the correct answer. Correct, no? So what we get the value of x at x equal to 2, we get f equal to minus 8 and u equal to 0. Since the force is not 0, the point is not in equilibrium. Correct, not? Go back to the fundamental definition of equilibrium. The net force has to be 0, na? Which is not. Hence, we get the correct option as option D. Dear Pratik, you understood?
Yes, sir.
Yes, sir. I also understood.
Okay, so let me go to the next one. This is MCQ number 4.
Sir, is it A?
Sir, A.
You got question number 4A. A is definitely correct answer. Exactly. So as all of you got it correct, so I'm not explaining you. Good that you got it correct. Let me go to the next one. Question number 5.
Sir, is it B? Sir,
Okay, yeah, Pratik, what you are saying?
is it B?
Yes, it is indeed B. Shrest, what you got?
Yes, sir. I also got the same
Okay,
thing.
correct. Yes, it is B indeed. Okay, so now let me come to the next question. That is question number 6.
Sir, D.
You got
Sir, D.
okay. Absolutely correct. D is the correct answer. Fantastic. Let's proceed to the next one. Question number 7 will be, available to you in another few seconds. You already have access to the question. Let me put it here. Yes, what you got for question number 7? Hello, Pratik, Tejas. Pratik,
Sir, is it B?
correct you are. It is indeed B. Dear Stressed, you got also B? Or you want me to explain this one? Hello, Stressed.
Sir, I got
You
A.
got A? Then let me explain. Okay. Let me first, draw the diagram, and let me explain. So the diagram, if you notice, is actually explains, represent the situation here. So first, what we get if you look into the initial position, and we get something like this. That in the initial position, what is the value of AP? Is square root of AQ square plus PQ square. Correct, no? Clear or not clear? And then which we get if you look into, you can look into this one also. P and Q, you can get it from the question. So if B traveled 7 meters downwards, suppose at the moment velocity of A and B are VA and VB respectively. So VA cos theta should be VB, obviously. And from the energy conservation, what we get, half MA VA square plus half MB VB square is equal to MB into GX. Correct or not? So actually I made a small mistake here. So it should be square. Correct or not? And then just apply all these things and you get the solution.
Sir, in the initial position, shouldn't AQ be 15?
Why you think so?
Because when it travels 9 meters, that's the final position.
Understood. But if you look into this one, that okay, let me understand which one you are seeing the 9 meter. Which one you see as
Sir, from the diagram,
from the diagram?
in the answer,
AP you found out.
position A, AQ's 15 meters. But in the diagram, like
Uh,
the final position,
yeah. Just a minute. Yes, what you said is correct. The velocity of A is the following figure. After it started from the rest in the position shows traveled. No, the point is that see, if you look into the diagram, the velocity of A in the following figure after it has started from rest in the position shown in the it traveled 9 meter along the frictionless surface. That means initially it was 6 meter, no? Initially it was at the 6 meter position, initial position. When in the initial position, A was where? A was somewhere like this, correct or not?
Yes.
After that, it has stretched to
Yes.
it gone to the new position of A, correct or not? This,
Yes.
this is 6, correct or not?
Yes.
I think that was the mistake happened, right?
Yes.
But, that mistake happened because you didn't go through the entire statement in the question in details, correct or not?
Yes, sir. My mistake.
Okay, no, that's fine. Learning from the mistakes is most important. Let me go to the next question. Yes, that is also a very good question. What is the answer you got, both Pratik and Tejas and Shrest? Very classical question.
Sir, C.
Absolutely correct you are. It is C indeed.
Yes, sir. I also got C.
Okay. As all of you got C, so I am not proceeding to explain. Now let me proceed to the next question. That is question number 9. Just give me a few seconds to put it here. Yes, what you got, dear students, for question 9?
Sir, I was getting
Sir,
4.5.
I'm sorry. You got the value of x is equal to 4.5 kilometer.
Yes, sir.
Okay. Okay. What about you, dear Pratik?
sir, I got D.
Okay. So it looks like it is not correct. So you got 2 kilometer, right? So let me explain this thing. So I'll explain in two different manner, and you will get the same solution.
Sir, is it B?
I'm sorry, no, it is not. Don't give answers. You don't change your answer so quickly. Okay. You need to really think and then answer. Let me just think. Provide you the traditional solution. And then what is meant by traditional solution? Just applying the fundamental concept of physics, and then I'll give a solution using rate measurement, using differential calculus. So now, if you look into it, that what is the initial kinetic energy is 900 joule, right? And half mv, so obviously we get half mv square is equal to 900, and from there we can find the value of initial velocity v. So let me put the solution here. I hope things are self-explanatory here, correct or not? After that, you understood that v initial is we get 10 meter per second, correct? As m is given 18. So if it loses kinetic energy at a uniform rate of 1 joule per second, then definitely power P is equal to F into V, that is m into dv dt into dx dt into V, that is minus 1 joule per second. So from there what we get? M into dv into dx dt into V by x is equal to minus 1. So mv square dv, because dx dt is nothing but v, so mv square dv is equal to minus dx, and we get v square equal to v square dv is equal to minus 1 by m into x, correct now? This one. Now after that what we need to do, we need to come to here, that we need to integrate both sides, okay, from 10 to 0 according to the question. So what we get, we give this as equation number 1, by the way. We give this as equation number 1. And if we integrate, so from there, apply the concept of definite integration, obviously we get x equal to 6,000 meter, which is 6 kilometer. Dear Pratik, you agree to me and stressed?
Yes, sir.
Okay,
Yes,
now
sir.
what I would like to say you is that I found another solution leveraging differentiation. How? Let me show it to you. And that alternate solution, if you look into it, it is quite understandable. So here we found dk dt. Because why we found dk dt? Because according to the question, dk dt is equal to minus 1. That's why I use the concept of differential calculus to reach to the same solution, 6 kilometer. Hope it is clear. Now let me proceed to the next question. That is question number 10.
Sir, is it B?
You got D?
B.
B? Okay. What about you, Shrest?
I got C.
Unfortunately, it is neither B nor C. It is actually A. So I hope I need to explain you. Let me first draw the diagram, followed by its explanation. I hope all these values you understood. Work done by the frictional force minus, that is equal to minus mu mgl. Work done by the gravitational force is equal to minus mgh. And work done by the given force is equal to wf. After that, what you will do, dear students, is that work done by all the forces acting on the body should be equal to the change in the kinetic energy of the body. So that means delta K is equal to W. Conceptual question. Correct, no?
Sir, it should be option B.
It should be option B.
Based on the answer
Okay,
only.
just a minute. MGH plus mu MGL MGH plus mu into L. You are so correct. You got B?
No, I got C by.
Sir, I got B.
You
I
got B. Okay, sorry. My mistake as well. Yeah, correct. Fine. No, I'll correct in my this thing. So it is definitely option B.
Sir, A.
Correct, you are. It is indeed A. What about you, Shrest?
A only, sir.
Okay, correct. As you got A, so I'm not proceeding further to explain this particular question. Rather, let me go to the next one.
Sir, is it A again?
Sir, A.
You got for question number 12A.
Yes, sir.
Correct, you are. This is indeed it. Let me go to the next question. Just give me a few seconds. What is the solution you got?
Sir, D.
Correct, you are.
Sir, D, sir.
You got B or D, Shrest?
D for donkey.
Correct.
Yes, sir.
Good. Absolutely correct. So let me proceed to the next one. That is question number 14.
Sir, D.
What about you, Pratik? It is indeed correct, dear Shrest. Pratik, you also got D or something different?
Sir, same thing.
Okay. All right.
Sir, is it C?
Correct, you are. It is indeed C.
Yes, sir, C.
Okay. So, and good. So now I can tell you that what we can discuss in our next class. In fact, in the next class, we'll be discussing on equilibrium. Right? I will take a test on equilibrium day after tomorrow. Correct?
Okay,
So
sir.
please revise. Appear as many as practice tests possible in the online test platform at KonarClasses, and then the question paper will be available to both the online platform and in the KonarClasses Lite app by tomorrow evening, 7 o'clock, say. And you need to appear that and send it to me by day after tomorrow, 6 o'clock, and we'll have our class accordingly. Thank you very much. Take care, and
Thank you, sir.
thank you. You'll get the class notes in another 15 minutes from now, and the video recording of this entire class in another 2 hours from now. Thank you.
Okay, sir.